Starting. Morning all, welcome to a random, rather off-the-cuff webinar from Spicule HQ. I'm in my booth today, so hopefully I don't annoy my colleagues too much. I wanted to test a few things, and it's sometimes just a bit easier to be somewhere you know. So welcome to my world. We are going to be looking today at how to deploy Openstack on a single server for development and testing purposes. It's something, or demo purposes. We spun one up the other day for a demo, and I figured it was worth sharing with the world just to show how it works, how you would do it, some nuances around the documentation, and then how you log in and deploy a couple of bits and pieces. So we will dive straight in. I'll warn you now, I have no script. It's going to be a bit of a ramble. Hopefully I remember the tweaks in the documentation that I worked through the other day, and we'll see where we get to. So if I just share my screen, I apologize, and I'll flip to a big fat black screen, but that's live. Let's see if I can get my face back on there. Give me 1 second. There we go. So hopefully everyone can see me. I have a big blank terminal. That with a bit of luck is SSH into a box, and people can see the top off. Yep, there we go. Okay, so I have a single server. This one's in Amazon. It's got 32 gigs of RAM, 8 cores, and a 300 gig SSD hard drive. That's going to be our test bed for today. Of course, it could be pretty much anywhere, but AWS seemed as good a place as any. And so we will go through the various steps required to get Openstack deployed. So first things first, when you're launching Openstack, it's going to launch it within LXD containers. For those who don't know what LXD containers are, you're missing out. They are system-based containers as opposed to app-based containers. So you can run a fully functioning Linux operating system within a container, which is great for testing stuff or running legacy applications or co-locating where you don't want to have ports clashing and that type of thing. And so I'll put it in the description afterwards, but for those of you who aren't aware, we are going to be working through this link here, the OpenStack docs for Openstack on LXD. So let's get started. First up, we need to clone the repo into my remote server. So once that's done, you can see I've checked out a whole bunch of files, and we will also install a few dependencies. So if I do, if betting goes wrong. I'm not entirely sure if this is required. I don't recall doing this the other day, but we will give it a go. This is LXD, so I can do apt remove LXD. No, I can't. Sudo apt remove LXD. The latest version of LXD is in snap version. You can apt install it, but the snap version is generally a bit more robust these days. And so we'll do sudo snap install LXD. For those of you who don't know what snap packaging is a cross Linux distribution packaging format that allows developers to package apps securely, which is cool. It sort of sandboxes them and puts various bits of the application into a read-only file system so that nefarious hackers can't log in and tweak your files without you noticing. And then we will stick some stuff in syscontrol just to tweak the LXD performance a bit. So we've got the snap LXD installed. First thing we have to do is initialize it. So sudo snap bin LXD init. And most of the stuff we can stick with is default, so we don't want to use clustering. We do want a new storage pool for this one, and we're going to use a directory base. Just ZFS for performance is recommended, but for this, we'll just use directory. We don't want to connect to a MAS server. We do want to create a local network bridge, so this will allow us to have virtual net for LXD containers, and for IPv4 we'll use auto. IPv6 we will go with none. We don't want it available over network. We do want to cache images automatically, and we don't want to see the output of that. And so that has gone and initialized LXD. And so we should just be able to test it by doing snap bin. There you go, and you can see it downloading the latest iteration of 1804, and it's called Excited Muskrat. So I should be able to do snap bin let's see exec excited muskrat flash. And I've now got a terminal open inside my container. So I know that LXC and LXD are up and running. There's a couple of things to note here. If I do snap bin LXC list, you can see that it's got a IPv4 IP address, no IPv6. Juju that we'll be using to launch this stuff doesn't support IPv6 yet, so we will stick with the default. But the other thing as well is, hold on, if I'm in here, we've only got one virtual network card. For this for Openstack, we need two. So there's a couple of tweaks we're now going to make to LXD. So it's not the LXD profile. And there we go. So we've created a profile inside LXD called Juju default. And we'll actually have a look at this just before I stick it in there. So this is the profile that LXD is going to load up. It's Juju default. Let me see if I can make it a bit bigger. Zoom. Oh, excellent. I can't zoom. Fair enough. So LXD default, it creates two network cards, ETH0 and ETH1, and so they will both head back to the bridge, but when you spin up containers from that point onwards, they will have two cards, and then it's got some pretty standard KVM, memory tweaks, and a ton adapter. So with a bit of luck, if I do Unsurprisingly, LexD's decided it's not going to like my config, so we'll try and figure out what's caused that. So, pasting it in, same error. Basically, you want to start the containers in privilege mode, and so we will try and figure out why it's not going to let us. Okay, so basically, in AWS doesn't support KVM stuff, so when we spin this up, it won't be very happy, but we will continue because I have one that prepared earlier anyway. So we've got our LexD profile in place. Next thing is to bootstrap your Juju controller. So Juju, for those who don't know it, is something that we use an awful lot here at Spicule. It's an application orchestration tool. It allows you to spin up applications that have a lot of moving parts, a lot of different services, have them connect together, understand their relation to one another. And it's great. We use it an awful lot for big data packages and also more and more Openstack deployments. So if we look at the config.yaml, the only thing we're going to do is remove this app HTTP proxy. So if I just wipe out that line. And then we will do Juju Bootstrap. I took install Juju first, of course. So again, Juju is snap, so snap install Juju Classic. It will think about some stuff for a couple of seconds. And there we go. So Juju is going to bootstrap the controller, which basically means it's going to start a LexD container that's going to be the controller instance for this deployment. The controller itself is like a web-based API that's got a MongoDB database and a few other bits and pieces behind it. An awful lot of Go code. I'm doing a bit of a disservice, so the canonical guys will probably kick off. But basically, it's a thing that manages all the other containers or physical servers, if that's where you deploy them to. And so it will spin up LexD container. We've told it to default to Xenial, so it'll spin up a Xenial container. There we go, it's already done. Download some stuff and stick it on the box. So if I do Juju status, we can see that we've now got a LexD controller with an empty model, which is exactly what we expect. And then what we're going to do is deploy Openstack. And just so I can show you a couple of things, we'll do it inside a screen session. So inside the repo that we checked out, there's a few different options. We'll go with the latest and greatest. But of course, if you've got a requirement to run and older version, that's more than doable. Again, we'll have a quick look inside this YAML file. So these are bundles, and inside Juju, a bundle is a collection of different charms. A charm is a piece of software that's encapsulated in some code to tell it how to deploy. And this looks reasonably ghastly, but you're not expected to write this by hand. This is all exported from Juju and then just stored in a YAML file. But basically, it's the definition of everything inside an OpenStack deployment and how it all hangs together. So we will do Juju deploy bundle, someone might have bundle Bionic Queens. So you can see it chucking quite a lot of stuff back to the terminal. And that is the configuration that it's now running through for the bundle, setting all the different charms into the model, and then adding the relations between the different services so that, you know, when you connect the various components together inside an OpenStack deployment, they know how to set their own config files, know where the other services exist in terms of IP addressing and ports and all that type of stuff. And so it does all that for you. Like, you know, I'm completely hands off at this point. And you can see it's deployed the bundle. So I should be able to do Juju status again. And obviously this time you can see that it's now populated with an awful lot of stuff that's waiting. So in terms of what Juju does, don't get confused with container-based deployments at the moment. Juju will deploy services to bare metal or empty servers. So it's not like instant access like you get with Docker-based deployment, but this obviously gives you an awful lot more flexibility in where you can deploy stuff, how it connects together, all that type of stuff. That's sort of coming with Kubernetes and the latest bits and pieces there, and Helm and all that type of stuff. But if you want to run stuff sort of down and dirty at bare metal level, then something like Juju will obviously allow you to hook all this stuff up relatively seamlessly. You know, as I'm talking, you can obviously see that there's more and more IP addresses getting populated. And if I just do snap in Lexi list, you can see here that Juju itself has started a whole bunch of Lexi containers and is just spinning those up. They've all been given IP addresses. So if I do Lexi exec and go into one, you can see what difference that that Lexi profile made earlier. So instead of having a single network device, we've now got Ethernet 0, Ethernet 1 for Lexi to utilize, and then, you know, OpenStack's expecting a couple of different network devices, and so even though they're virtual, they still get their own IP address and their own MAC address and all that type of stuff, and so the different containers can start routing to them. And so, you know, as if I do watch color, Juju status color, you can see this now refreshing, and as it goes through, it installs the charm software on each one. It will then download the various components that is required to run that specific OpenStack component onto that container in this case. You know, but if this was obviously a physical deployment, there's actually no difference. It does exactly the same thing. You would need in this bundle to have how many machines there are, 20 odd. 22, 23 machines. But that's not necessarily how you would deploy it. You can obviously co-locate different bits and pieces. You could scale stuff differently as your cluster, your OpenStack cluster increases in size. Of course, you'll have more and more machines. So, you know, this is a good starting point, but this is just a bundle to demonstrate how Openstack hangs together, and so putting stuff into individual containers just makes life easier. But as this continues to work, it will go through the installation phase until stuff gets ready. So rather than sit here and wait for that to happen, I figure we'll just jump to the end, and I can show you what happens in the next 20 minutes. So your cluster will go to the internet, it'll download all the stuff, it'll install bits and pieces onto its specific servers. Then if we flick to this screen, you can see how there are now a whole bunch of different bits and pieces installed, active. The agent is idle, that's what we'd expect to happen, but you can see how the status message is now, unit is ready. And so we've got Ceph for storage, we've got Nova Compute for computational execution of containers of virtual machines in OpenStack's case. The Celiometer for monitoring all that type of stuff, Keystone for authentication. They're all deployed to their own virtual machine, their own container, but we're still obviously just on one physical machine. And this is great for us to be able to demonstrate how OpenStack works, or run a very light workload just to make sure that what we're trying to do is going to work. If we're developing an application that needs to be able to leverage the API, we can obviously make sure that the API works, the storage API works, all that type of thing, without having to run any more than the cost of a single server. This one's in OVH. It costs like 80 quid a month. So if you're developing an OpenStack instance or platform, this is a great way to be able to do it. And I don't need to know anything about how OpenStack is actually configured. It's just something that just works. So what I've done here is obviously get it all set up. There's my SSH session is timed out. So let's just kill all them off. So there's actually two things I want to try and show you. Which port does it go on? Give me 1 second. So -L. So what I'm doing here is I'm SSHing into the box is because we're running inside containers. We can either do some IP tables routing to expose the ports to the wider world, or we can just port forward specific ports to my local server so that we can get access to that stuff locally. So I've now logged into the box, and you can see that I've port forwarded port 80, which obviously is the web port. I've also port forwarded 17070, which is the Juju GUI, because I want to show you how that type of stuff works in terms of usability and how Juju can offer ease of use and ease of administration. So if I switch my Ubuntu user, so we're back here. You can see how it's all set up, and then we can also cd into that same OpenStack on LXD repo, and we can then source OpenRC. And when you source the OpenRC, it then sets a whole bunch of information into the environment variables that we can then use. So then our OpenStack commands will start to work. So you can do OpenStack server list, for example, and you can see what it's returning back from the OpenStack cluster. So these are all running as containers inside my LXD container, KVM containers inside my LXD container. But of course, this is all command line stuff, and I want to show you how it works in real life. So I flip this over here. Just make it bigger. So for those of you who don't know the Openstack dashboard, this is it. You know, OpenStack is API compatible largely with AWS stuff, you know, but obviously has a very distinct user interface that is different from AWS and the way AWS stuff works. And this is what you get when you log into the LexD, OpenStack on LexD user interface. As an admin, you get to see obviously more than your users would, but you get a test domain and a test project. And so with OpenStack, obviously you could have an awful lot of different domains and an awful lot of different projects under those domains to help separate your users across different platforms, or if you've got different customers on your OpenStack cluster and that type of stuff, you can obviously keep them segmented in a multi-tenant fashion. And so inside the admin area, you can then see what hypervisors you've got available, and your hypervisors are where the workloads go and get executed. And so we've got one that's a nice LexD host that's sitting there, and they will provide the compute power. And obviously it can keep track of what's available to the servers from the different hypervisors. You can then aggregate different hypervisors into the same groups. So you deploy stuff in the same place, that type of thing. You've then got all your instances that are running. So you can see we've got Steven's server and a Migsolve server and various other bits and pieces. What images they're running, what size they are, you know, whether they're active and what their state is. Inside flavors, you've then got something that if you've used EC2, you'll be well aware of. You've got different flavors, styles, different server capacities. These are arbitrary, so you know they're designed to look like AWS server sizes, but of course you could call them anything you want. There is no real requirement for giving them AWS names other than convenience, because people sort of recognize what they look like. You know, if I wanted to create a new one, create flavor, you can then set your vCPUs, the amount of RAM, the amount of disk that's available by default, and obviously who can access it, because you might not necessarily want everybody accessing the same instances. If you've got GPU specific ones or whatever, you might want to be able to limit who gets access to them, or different sizes. You might not want to let certain people have access to the biggest sizes ever. So you can obviously tweak that. And then images are obviously what gets installed into that virtual machine. So the default image we've got here is Xenial, but you could have pretty much anything you want. And so as an admin, you'd really do this on the command line, but you can obviously you know, upload your image, be it a Linux image or another operating system. There are many of them. You can select what type of format it's in, if there's a kernel, and RAM disk and all that type of stuff. And obviously whether it's public or private. So again, you can have a bunch of images that are specific to a single user or single group. And you can configure all this in terms of security. We're not going to go into that in this session. But if I then go to the compute section, this is like, as a user looking at the project, I can see how much of my compute has been used up, how much my storage has been used up. If I then wanted to launch a new workload, it's really straightforward, you know. And this is the great thing about OpenStack, is you get the power of the public cloud on private hardware, or on a single server in this case. So I can do YouTube demo. You can set up, you can obviously launch more than one server. So let's launch 2. And then whether you want to launch from an instance or volume, that type of stuff, and how much volume size you've used. chuck in the image that you want and the server size that you want. And then if you've got different networks available, you can select your network. Security groups, of course, is like port-based stuff, what ports you have open, what ports you don't have open. Key pairs are SSH keys, so you can log into a box. That's always useful. And then if you stick in too many, it will stop you being able to load all those servers because your quota has been exceeded. So stick it back down to 2, hit launch instance. And with a bit of luck, here we go, you can see it scheduling, it then allocates a block device, starts installing the image and that type of thing. So when they're up and running, you then have far more options, stuff you can do with it, stop it, start it, archive it, attach volumes to it, the usual AWS stuff. If you can do it in AWS, you can basically do it in OpenStack. And so, this is why we enjoy working with this type of stuff, and it adds another level of flexibility to the work that we do. We have a whole bunch of OpenStack clusters running in different places, and because you can just spawn virtual machines. It means that you don't, as a systems administrator, have to keep watch over every server quite as much as you would do in the past, because you can allow your data scientists and similar to just spin up their own servers, make sure they don't do anything stupid, but spin up their own servers and process their own data. And that worst comes to worst, you can switch off the server and it'll go away. Inside Object Store is similar to what S3 users know as buckets. So, you can create a container, which is an S3 bucket. Other object stores are available. Create a container, upload your files and stuff to it. This is obviously done by the web UI, but again, it's API compatible, so you can just dump files and stuff to it. And then provide access to it. And so that's, a quick whiz round OpenStack. And then I'm hoping if we do, helps from which port I stuck it on. One, 2, 0, 17. Hold on, let me find the Juju GUI. It's gone missing. IP address I want. Try again. So if I go back here, there we go, it's more like it. We'll ignore the SSL issue because it's running locally. And then I will copy my password out of there, stick it in here. So this is Juju GUI. I just want to show you this briefly. This model looks interesting, but it's a complex model. There's a lot of moving parts. But each one of these round circles is a service, and the service is, in this case, Neutron Gateway or Glance and all that type of stuff. And so, using Juju GUI or the Juju command line, scaling capacity on your server, be it physical servers, if you've got a whole bunch of physical servers, if you provision this on MAS, then you're absolutely quids in because you can just provision more MAS capacity. and spin up more and more compute power. If you want to be able to deploy more and horizontally scale, then you've got like, Nova Compute. If I want more units of Nova Compute, I want to start 2 more, and I want to place 1 unit per machine. Hit the confirm button. It's the day when Juju GUI decides it's not going to play ball. Okay, that works slow. Juju, add unit, enter Nova Compute. There we go. So you can see now that there's 3 units. There was 1, there's now 3. 2 of them are pending. So you can see down the bottom that you've got these 2 that are waiting. And these 2 machines, so it's going to start up 2 more LXD containers. And this is the great thing about, testing this stuff. It's now just, without me doing anything, I'm going to launch 2 more LXD containers. And it will now go and install Charm software and then the Nova Compute software into those containers, and I will be able to deploy workloads, get registered automatically, be able to deploy workloads and what have you to it. And it's absolutely fantastic. Apart from like writing some convenient stuff into the command line because it's quicker and easier for someone who knows what they're doing, it just makes life an awful lot easier. It means I don't have to go and figure out how to configure an OpenStack cluster, using config files and stuff. The nice guys at Canonical have packaged this up in a way that allows me to go and deploy this quickly and easily for customers and clients, and that's why we love it. So this has been a whistle-stop tour of how to deploy OpenStack on a single server. Of course, it doesn't have to be a single server, as I keep saying. It can be, deployed to a whole range of different physical infrastructure. Bringing the power of the public cloud privately to reduce costs and help businesses remain agile and flexible is something that we're very bought into here at Spicule. And so, if you're interested in deploying an OpenStack cluster, we'd be more than interested in having a chat and seeing how we can help. So if you do want to get in touch, swing by our website, spicule.co.uk, email info@spicule.co.uk, or give us a call and you can chat to the lovely Stephen. We'll be back later this afternoon, we'll be back on Monday morning with the next 60-second data download. And so until then, bye for now.